All right, today we're going to talk about graphing both linear equations and inequalities and also systems of equations and inequalities. Please make sure you have your calculator with you. This is a very heavy calculator work, which is awesome because you can get to the solutions pretty straightforward pretty quickly if you know the steps on the calculator. Also, please have some paper for some notes. Jot down anything that you need to, okay? So this is just a quick review of the basics. We have graphing on a number line and we have graphing on a coordinate grid, a whole graph, right? Number lines we do not use very often, but this is just a reminder. If I had something like x equals 3, that means x is just right here. That's it. So we just put a dot on 3. But if I have something like x is less than or equal to 3, less than or equal, remember that's going to be a colored in dot. If it includes equal to, then it is colored in. And it's less than, where are the numbers less than 3? 2, 1, 0, this way. So I would have the shading. So the biggest difference between equations and inequalities when we're graphing is that equations will have no shading. Inequalities will always have shading. So let's look at it if we had it on a coordinate grid, if we're graphing it. X equals 3 is just this vertical line that crosses through 3. Remember, when we have a vertical or a horizontal line, we call those special lines. We ask ourselves, which axis does it cross, crossing through the x-axis, and where? At 3. That's x equals 3. So that is just this vertical line. But if we come down and we do x is less than or equal to 3, I still have this vertical line at 3. I am making my line solid because of the equal to. Remember, a solid line means we're including the line. A dashed line means it does not equal to that line, but all the stuff to one side or the other of that line. Now that I have my line drawn, I need to note that it's where x is less than this line. Well, here's 3. Where are the numbers less than 3? 2, 1, 0. My shading is going to go this way. Oftentimes, what you're going to be asked is something like, is the point -1, 1 part of the solution? -1, 1. Is that part of the solution? It is because it falls in the shaded region. The solution to an inequality is the entire shaded region, okay? Keep in mind, you know, these have arrows, they go on forever, so this shaded region goes on forever and ever. Same thing with the shading here. This arrow means this goes on and on and on and on. All the negative numbers just to infinity, okay? So let's try something like this. Graph 3x minus 4y is greater than 8. All right, before we can graph anything, equation or an inequality, we know that we need two things. We need a slope, and we need the y-intercept. So m equals blank, b equals blank. I want to see that on your papers. Now, I see that this inequality is given to me in standard form. If I can manipulate that into slope-intercept form, then I will easily be able to pull out my m and my b. So that's what I'm going to do first. I'm going to take my 3x minus 4y is greater than 8, and I'm going to solve for y. Okay? In order to get y by itself, I'm going to start by subtracting 3x from both sides. Remember, 8 and 3x are not like terms. Those cannot be combined. Negative 4y is greater than negative 3x plus 8. I can write the 3x before the 8 as long as the 3x remains negative and the 8 remains positive. Watch your signs, very important. Okay? Now I want y by itself, so the next step I'm going to do is divide by negative 4. Ding, 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 ding. I feel the alarms going off in my head. I know that any time that I have to divide both sides of the equal sign by a negative number, I must flip the inequality sign. That is the one special rule for inequalities that differs from just solving an equation. So before I even do the math, I'm going to go ahead and get that sign flipped. I do not want to forget that, or else I've just ruined my whole problem and I'm going to get the answer wrong. All right, so my negative 4's canceled out. I have y is now less than negative 3 over negative 4. I'm going to leave positive 4. The negatives cancel out. And 8 divided by negative 4 is negative 2. So here is my equation written in slope-intercept form. Now that I have it written in slope-intercept form, I can say, okay, well, my slope is 3/4. My y-intercept is negative 2. Don't forget your signs. That'll mess you up. I'm going to plot the y-intercept at negative 2. I'm going to use rise over run, my slope. I'm going to rise, starting at that y-intercept, I'm going to rise 1, 2, 3, run 1, 2, 3, 4. All right, I have my 2 points, but now I need to look at my sign. Because it is not equal to, only less than the line, I do not make a solid line, I make a dotted line. So I come in with this dotted line, and what this is telling me is that any point that lands on the line is not part of the answer. Why is all the things less than the line? Well, the line crosses at negative 2. Where are the numbers less than? Negative 3, negative 4. So I'm going to be shading this way. So if I was asked, is the point, we'll just go with 1, negative 1 again. Now, negative 1, 1, a solution? No, it is not. It's not in the shaded region. Is the point 4, negative 1? 1, 2, 3, 4, negative 1. Is that a solution? Yes, it is. Is the point 0, negative 2 a solution? No, it is not. It's on the line, but this is not inclusive, so it is not a solution. Okay? All right, the other thing we're going to be looking at today is systems of equations and systems of inequalities. So let's go over a few quick reminders. First thing, with systems of equations, we have 3 possible options. We can have 2 lines that cross each other in one place, and we have 1 solution. If we have 1 solution, typically we're going to be asked, what is that solution? And we're going to give the numbers. Let's say that's at negative 2, 1. The solution is negative 2, 1. Because the solution of a system of equations is the point of intersection, where the 2 lines cross. Okay? So the other option would be, okay, what if they are, ooh, that's not great, but what if they are parallel lines? Parallel lines never cross, so they have no solution. A system of equations that is parallel have no solution. If I'm looking at their equations, how can I tell that they're parallel? Parallel lines have the same slopes. So if you see 2 equations and the slopes are the same, they're parallel. That means there is no solution. There is no place anywhere on that line where they are going to cross. Okay? And the final one is a line that is then laying directly on top of another line. They are actually touching each other at every single point. So infinitely many solutions. There's an infinite number of solutions. There's no way that I could list every single point that lays on this entire line forever and ever, right? Those would be the same exact lines. They would have the same slope and the same y-intercept, right? So if you're looking at the equation, you can see that. Okay, so we are looking for where do the lines cross each other. So let's try one. Let's solve this equation, which is this system, which is negative x plus 3 and y equals 2x minus 1. Here comes your calculator work. Let's get our calculator. We're going to go into the calculator, and we're going to enter the equations into our y equals. I'm going to hit y equals negative x plus 3, 2x minus 1. I have my equations entered. Then I'm going to hit graph. And there we go. We are graphing our equations. Next, I'm going to make sure that I can see where they're crossing on my screen. If I can't see where they're crossing, I'm going to adjust my window so that I can see the point of intersection. Okay? But here we are. I see my cross, so I'm going to say second trace. Number 5 is intersect. I'm going to hit enter. It's going to ask me first curve. I just hit, it's already on the first line, so I'm going to hit enter. It's automatically going to jump to the second curve, so I'm just going to hit enter. It's going to ask me to guess. I'm going to hit enter. So that was enter, enter, enter. And I can see that these lines cross each other at 1 1/3, comma 1 2/3. That is the point of intersection. That would be the answer, the solution to this system of equations. So I'm going to say 1 1/3, 1 2/3. There's the solution to this system of equations. Very calculator heavy work. I really didn't even have to write anything down at all. So if you're working on your assignment and you do it all in the calculator, you can write second trace number 5, and I will know that you knew how to plug that into the calculator. All of this information that we just talked about is a part of your brain dump. You have the different types of solutions, you have the calculator information, so make sure that you're learning the brain dump so that you have all this information right at your fingertips when you test, okay? Now, what if I turn that system of equations into a system of inequalities? Notice I'm still doing plus 3 and 2x minus 1. But this time I have y is less than negative x plus 3, and I have y is greater than 2x minus 1. Now it is more important that I actually graph it by hand, not just on my calculator. So I'm going to go ahead and plot this real fast. Well, my y-intercept is 3. And my slope is negative 1, so I rise 1, run 1 to the left. Rise 1, run 1 to the left. And that is y is less than, so that is going to be a dotted line, not equal to. Then I have the equation, negative 1 is the y-intercept, rise 2, run 1. And this one is y is greater than or equal. So this one's going to be a solid line. Okay, so for my first line, y was less than the line. So my shading would be here. For my second line, y was greater than or equal. So we have the solid line and then the shading here. Okay. The solution to a system of inequalities is what? The solution to a system of inequalities is the double shaded region. Double shaded region. Okay, where both of the colors are crossing each other, that's my solution. So if you were asked, is the point negative 1, 1 a solution? Yes, it's right here. It's in the double shaded region. What if you were asked the point of intersection? Is the point 1 1/3, comma 1 2/3 a solution? It lands on a dotted line, which would make it not a solution, but it also lands on a solid line. So this would be a solution to this system of equations. Okay? Anything in this region, or this region would not be. All right? Okay, let's look at a couple star-like problems. Okay? All right, it says, what is the solution to the system of equations represented by these tables? All right, I'm given 2 tables. I know that if I'm given a table, I can write the equation using my calculator, right? I can go to Stat, Edit, and I can type in the tables. This is a Stat Edit problem. Notice how much calculator we're using. 1, 2, 3, 2, 5, 8. Stat calc, I'm going to go to linear regression. And I knew it was linear because the whole topic here that we're covering is linear systems of equations, okay? So y equals 3x minus 1. All right, that is the equation for this table. Now I'm going to do the other table. Stat, edit. I'm going to clear out what's in there. Up, clear, down. And then I'm going to type in the other table. -6, -5, -4. Over here I have -19, -16, -13. Okay, then stat calc, linear regression, enter, enter, enter. And I get y equals 3x minus 1. All right, the equation for this table is y equals 3x minus 1. The equation for this table is y equals 3x minus 1. What do you notice? Hopefully you're recognizing that if we graph this, -1, rise 1, 2, 3, run 1, graph it, and the second one, -1, rise 1, 2, 3, run 1, graph it. I have lines that land on top of each other. So the solution to the system is that there are infinitely many. Every single point on that line is a solution. Now, does that mean that the point -1, 1 that I keep using over and over is a solution? -1, 1. Is that a solution? No. It's an infinite number, but it's not every single number. So it's not all solutions in the whole wide world. It's just all the points that land on this line. Okay? All right, let's stop there. Make sure that you are clear on graphing equations and inequalities, and then also systems where you'll be graphing more than one line on the same graph. Use your calculators.